Okay, so we're going to switch over from code, and we're going to talk more about the commands. Uh, Monday. CAD does Mondays. So we're going to talk about commands a little bit more conceptually so that we know how they're going to work. So with a command-based robot, we said there are three things to worry about. One of the foundational things is subsystems. Now remember, subsystems are what make up your robot. They define what the robot is and what the robot can do. Right? Now, subsystems define, again, what a robot can do, but a command is how you tell the robot to do something. It is how you command the robot.
Then you must tell it how to do.
When to do. The thing that tells it when to do is a trigger. So you define a trigger so that when some condition is met, it fires off a command. And then when that command gets run, the command tells the subsystem what to do. And so this is a nice thing where the subsystems, the triggers, and the commands know very little about each other. In fact, a trigger doesn't know anything about a subsystem. Subsystem knows nothing about the trigger. The command knows a little bit about the subsystem, and the trigger knows a little bit about the command. But it's a way to kind of break up your code so that no one part of your code has to know a lot about any other part of your code.
For one person in front of you keeping the two friends together.
Yeah, exactly. So when we look at commands, we want to look at how we issue commands. The first thing we want to look at with commands is something called the command factory. Now, if y'all had to take a guess, what does a command factory do?
It produces commands on an assembly line.
It produces commands on an assembly line. And you have already used the command factory. Whenever you see this, commands dot, this is the command factory. So looking back at robot container from earlier, where we have this commands dot run, it's got that commands dot. That means this is part of the command factory. This is how we make commands. And there's a lot of different ways to make commands. The ways you'll see, we'll hold off on that. So there's a few ideas. One kind of command is what I like to call a do nothing command.
Do nothing, do something. Do not.
And so it's going to be when you see commands dot none idle wait second
Wait a second.
wait until. So these are all different ways to write a command that does nothing, but nothing's a little misleading. Commands.none is literally a none command. It doesn't do anything. It goes and it finishes. That's all it does. Idle is a way of telling the robot, hey, don't do anything until you get interrupted. So command.idle is a way to say, hey, just hang on. I'm going to send another command later. Just wait until then. Yeah.
Wait a second.
Now, command wait second is very similar to idle, but you can tell it how long to wait. So again, commands idle is wait until something happens. Commands wait second is wait this number of seconds.
Wait until.
Yeah, and then wait until is a way to wait for a special condition. So idle is wait for another command. Wait second is wait for a period of time. Wait until is wait for a condition to be met. So some trigger, basically, yeah. So those are your do nothing commands. They do have their uses. You just don't use them as much as you use other commands. The next group of commands we've got are called instant commands.
Instantly happen.
Close.
Instantly.
So most commands are going to happen when you issue them. But instant commands do this thing where they run and then they finish. And so the idea is it will initialize, it will run, and then it will be done. And it doesn't continuously run. And the way you access those is through, again, the command factory, commands dot run once. So if you see commands dot run once, that's saying, hey, run this command, do one iteration, and then you're done. It's over.
It's already broken. You broke it. It's your fault.
Another kind, it's related to instant commands, it's called a print command. So if you're looking for a way to log text to the console, you can do that with commands dot
Oh, print.
print.
We already have that.
I literally learned this today at Python.
That's in container. It's return command software.
This might be something different, but oh yeah, so yeah, if you look in the so there is a print command as the autonomous command. So right now there's no autonomous in this code, but they've set up a default command of just a simple print command. So it's going to do something, it's going to print some text, but because it's a print command, that's all it's going to do.
Print nothing.
Yeah, but it's printing something. There's a message.
No, it's on the command configure. That's all it says.
Yep. So we also have what are called run commands.
Weird.
Now, to access a run command, you do commands dot run, which is going to look a little similar to commands dot run once. The difference is run once initializes, runs, it's over. Run initializes and just runs until it gets interrupted. And we've already seen this one as well, because that's the one that we wrote for our default command, which should make sense. We want the drive command to run continuously until it gets interrupted. So hopefully that idea makes sense there. We've got a few others. We've got the start end command. And how this works is it's going to initialize, it's going to run a command one time, and then it's going to run a different command. And it's going to, so it's going to wait until the first one gets interrupted. And so you access this with commands dot start end. And again, it's going to do two commands. It'll do command 1, command 2, and it will not run the second command until the first command gets interrupted, even if that first command finishes early. Related to that, though, we also have what are called run end commands. And you access that with commands dot run end. And so this is a special case of some other kind of command called the functional command. And in this case, it's going to behave exactly the same as start end. So you're going to have two commands. The second command is not going to run until the first command gets interrupted, but the first command isn't going to run just one time. It's going to run continuously. So start end is like run once. Run end is like run. But in both cases, the first command has to be interrupted. It's not good enough for the command to just finish. Something has to say, hey, stop it. So these are all kind of what I would call like the basic commands. The ones you're probably going to use most: run once and run. Sometimes you have an action that you need to run one time and then it's over. Other times you have an action you need to run repeatedly. That's not to say you won't use any of the others. These are just the two you're going to use most often. But here's what is great about commands. Commands are composable, which means you can make a really complex command by making a bunch of simple commands. And what that takes the form of are called command groups. And
I thought you were gonna say command raise.
so one type of command group is called a sequential command group. And that's where you say, do this, then do this, then do this, then do this. So if you've got a drive subsystem and an elevator subsystem and a depositor subsystem, you can say, drive to this spot, then raise the elevator, then push out what you're holding. And you can do that as one command that is a sequential group of 3 simple commands. And so you can define very simple behavior in each subsystem, and you can build complex behavior by just composing these commands together.
Command dot run once, then the sequential command, drive forward, pick up, shoot.
Yeah, there's a couple of ways to write it, but you could say commands dot sequential, and then inside that you would define those commands. There's another group called the repeating sequential,
Pizza sequence.
which is the exact same thing, but maybe you want the cycle to repeat. So drive, raise, deposit, drive, raise, deposit, drive, raise, deposit. Yep.
Couldn't you just achieve that with command dot run and then run that sequential command?
So that's one of the nice things is there are a lot of ways to do the same thing. Some ways may it's hard to say be better, but they might feel more natural in the case. So it's always going to be a case of what makes the most sense for the way I've written the other commands.
Because the command dot run and then having it constantly run the single sequential
Mhm.
thing will allow you to easily turn it off.
Yep. So this one would be commands dot repeating sequence. So those are the two sequential groups. The other kind are called parallel groups.
Happen at the same time.
Happen at the same time. Now, one thing to remember, because of the way commands work, you can't have one subsystem do 2 commands at the same time. But you can have 2 different subsystems do 2 commands at the same time. And in fact, there's actually 3 parallels.
Ran.
There's group, there's race, and there's deadline. So parallel group is run by commands.parallel. And the way it works is it just runs all the commands until they're all finished. So if you say command 1, 2, 3 on subsystem ABC, it will run all 3 at the same time, and it's not over until all 3 of them are over.
So this allows you to do multiple commands at once.
Yeah, so for example, with sequential, before we said you want to drive, then raise, then deposit. Well, why can't you drive and raise at the same time? You would use the parallel group to rise and drive, and then you'd use the sequential to combine that with the deposit.
This gets past the part where you can't have multiple commands at once, but if you have multiple commands in a single command, then
It's still the same problem because the individual commands have their requirements. So it's still the same. You can't have one subsystem try to do 2 things at the same time. But you can have multiple subsystems doing different things at the same time. That's okay. The other 2 kinds of parallel, you've also got race, which you get by commands
Two people groups together.
dot race. Say again?
Mixing 2 people groups together.
No.
no.
No. So race in this case is just like a race, right? you've got two commands going at the same time. Group would finish when all of them have finished. Race finishes when the first one finishes. So if you've got, this one thing that you're kind of doing on the side while you're doing this other higher priority task, this will finish when the faster one finishes.
So when the arm raises, it stops.
Yeah. So if you're saying move and raise the arm at the same time, and you're doing it as a race, it will probably stop when the arm raise stops. Similar though, you've got the deadline, which is commands dot deadline. Now race was stop when the first one stops. Group is stop when the last one stops. Deadline is stop when the one I want to stop stops. So if you've got 5 commands and you're like, I really need you to stop when command number 4 finishes,
When it's done driving.
whether it's the fastest or not. Whether it's the fastest or the slowest or somewhere in between, you can say specifically, hey, stop when this one's done. And so these are all things that you could do without WPILib, but these are all what we call syntactic sugar. These are things WPILib is doing for you, and you can just use them out of the library. So let's see, we're saying the same thing, can't do that. There's a few other types of commands that I don't want to get into right now because they're a little bit more complicated. The ones we've gone over, most of the commands you're going to write fall into one or more of these categories. But in this case, they're all using this commands dot, which is our command factory. And there's other ways to chain commands together that we'll hopefully look at later. But any questions on the command factory?